we are on applications of module 2, and I already discussed on the previous video about the tangent and normal lines. Okay, about the tangent and normal lines. Now we are ready to proceed to your unit 2. Okay, increasing and decreasing functions. So this is what we discussed. Please be reminded of your activity to be submitted on your canvas. Okay, please submit this one in your canvas before we will start, or we will have the discussion or the question and answer on this part. Okay, so unit 2 under application is the increasing and decreasing functions. If we say increasing and decreasing functions, we are talking here of the movement of points along a curve. Okay, along a curve, which is defined by the characteristics of the interval. Okay, and that interval, we write that one in this manner or in this way. It means, okay, interval from A to B. Okay, I will explain that one later on. Okay, so again, decreasing or increasing function, we are referring to movement of points along a curve, which is defined by the characteristics of the interval where it belongs. Okay, so the movement of the points is defined by the interval where that point is belonging to. So if we say intervals, these are range of points with single flow of movement. Okay, if we say single flow of movement, either that is rising or that rises from left to right, we call that one the increasing interval, or that will falls from left to right, we call that one the decreasing interval. So if you try to look here on our figure here, okay, in our figure, the red is your function. Let's say that's the y function of x. If I will try to follow this one, okay, I will consider here points. Let's consider these points A, B, C, D, and E. Okay, or in this A to B, or that is the first interval. Okay, if you say interval again, that is a range of a values or range of a point wherein the flow of movement is single. So let's say from A to B, the flow of movement, if you say flow of movement, that is the movement of the points. So the points here within this A to B are all going up. The movement is going up. Look at this. From A going to B, that is connected by points that is going up. By the way, functions are consisting or consist of points. These are series of points before it became a line. Okay, so this line is composed of a lot of points. So that is the meaning of that. So again, interval A to B means from the interval A to B, okay, wherein that is under your point A to point B, the flow of the point is going up. So we call that one the increasing, okay, that rises from left to right. So that is the increasing interval. So ibig sabihin lang yan, going up from A to B. How about that interval? Okay, the interval B to C means from B to C. From B to C, this interval, okay, from point B going to point C, that will now be going down. So the movement is going down or decreasing. It falls from left to right. So going to the right, it is going down. So that is a decreasing interval. Okay, that is a decreasing interval. So your second interval B to C is decreasing. And how about C to D? Of course, that is going up. So that is increasing. And then D to E, that is also going up, which is increasing. That is what we meant by interval. Okay, it is a range of points wherein the movement or the flow of movement is single. It's either going up or going down. So relating to this interval, we have what we call as the critical points. Okay, what are these critical points? We call that one the critical points. Okay, these are the points on the curve whose tangent is a horizontal line. Okay, that serves as boundary of intervals. As I've told you, these are intervals A to B, B to C, C to D, D to E. And actually, these intervals are separated by points. Yes, those are separated by points. And these points, these are what we call the critical points. Okay? And what is the uniqueness of that points from the other, that critical points, or what is the, yes, the uniqueness of that critical points compared to the other points within this line is that these points have tangent that is horizontal. Okay, these points has a tangent of horizontal line. So if you say horizontal line, that is a flat line. So since we are talking here of slope and derivative, for it actually from the previous video, we discussed that your slope is the first derivative. Slope of the tangent is the first derivative. So it means that if that is a horizontal line, what is the slope of a horizontal line? Again, that is 0. Okay, so it means that critical points has a slope, or yes, slope of tangent of 0, or a first derivative which is equivalent to 0. Okay, we have here types. We have here types. We have here what we call as the maximum, minimum, and inflection. Okay, before that, look at this. This is the explanation of that. Okay, look at this. If I will consider other points here, look at this orange point. Okay, if I will consider that, I will draw a tangent. Okay, that is either going up, because again, the slope or the points here is in increasing, or it means that the slope in any point here is going up or positive. So that is increasing function. Within this going down or decreasing function, any points here, if I will draw the tangent, that is going down. That's why we call it decreasing function. Now, if you will try to look here at point B, point C, and point D, okay, if you will try to look at these 3 points B, C, and D, these are what we call as the critical points. Why? Because if I will draw the tangent, those are these black lines. These are now horizontal. If I will draw the tangents here, those are horizontal. That's why that is critical points, because the slope of the tangent is 0, or simply that is horizontal. And we have here types. Okay, I will discuss. Okay, what's the first type? We call this one the maximum point. If you say maximum point, that is a summit point on the curve. If you say summit, that is a highest point. Okay, it is a highest point on the curve where change happens from increasing to decreasing interval. So if you try to look here in the figure, the example of that is point B, that is a maximum point. Why? It is a summit, or it is located on the top most of the curve. And the uniqueness, or the uniqueness of that critical point from the other is that it separates going up or increasing function or interval and a going down interval. So it is underlined here, it is emphasized. A maximum point is a point where the change from increasing to decreasing interval happens. That is your maximum point. Okay, going up, going down interval, and between is your maximum point. Before it will go down, okay, look at this, the point is going up, but it will be going down later on. So before it will go down, it will be having this maximum point before it will start going down. Okay, that is maximum point. Increasing to decreasing interval, the point in between. Okay, minimum point, this is the reverse of maximum. If you have there a summit, and minimum is what we call the bottom point on the sag. Okay, this is the summit, here is the sag. The lowest point or the bottom point on that sag is the minimum point. Okay, this is a point where change happens from decreasing to increasing. So this is the other way of maximum. And maximum, that is increasing to decreasing. And your minimum, that is decreasing to increasing interval. Okay, so that is the middle point of the decreasing to before it will go to increasing interval. Okay, that is minimum point. And if you try to look here on the figure, there is a point here wherein the intervals on the left or the side are the same. Okay, we call that one inflection point. It is a point on the curve between intervals with same movement. Okay, we call this one same movement. It is either both increasing, so it's either like this, okay, both of the intervals on the left and right side are both increasing. The point between is inflection point. Okay, or the other case is that both of these intervals are going down. So both are going down, which will be having the inflection point in the middle. So that is the difference of this inflection from the maximum and minimum. Maximum and minimum, these are the left and right side intervals are different movement, and so with your minimum. But in your inflection, it's either going up, or going down, going down. Okay, that is inflection point. Could also be known as a point where concavity changes. Okay, this is also a point. Your inflection point is also a point where concavity changes. If you say concavity, that is the opening. That is the opening of your curve. I will be explaining that one later on if we will go on that part. Okay, look at this. If we say concavity, that is the opening of the curve. So look at the interval C to D. That is going up. It is opening. The curve looks like opening upward, isn't it? Right? It is opening upward. Pataas po yung opening niya. While on the interval D to E, look at this. It is now opening downward. Going up and then, opening upward and then opening downward. That is what we call concavity. I will be explaining that one later on. Okay, so that is the uniqueness also of your inflection point. So that is increasing and decreasing function. Okay. We have intervals. It is a range of points with single movement. It's either going up, going down. That is what we call interval. And the points between those intervals are critical points. It's either a maximum, a minimum, or inflection point. Okay. So that is for this unit. In relation to that, to the increasing and decreasing function, we will focus now on the critical points. Okay, so here on the third unit, we are talking here of the maximum and minimum values of a function. So actually, we are just finding there if the values of the maximum and minimum. Okay, points on the function. If you will plot that one, we call that one points. If you will plot, but if that is just equation, we call that one function. Okay, we call that one values of x and y or y. Okay, so if we say maximum and minimum, okay, so it says there that to find the critical points of a function, as I've said a while ago, critical points, set the first derivative with respect to x of the function to 0. What do we call that derivative with respect to x? That could be your y prime if your other variable is y. So that's dy dx. First derivative with respect to x. So that is y prime. Okay, set that one to 0. Why are we setting your first derivative to 0? Because if you will go back to the previous slide, it says there that all these critical points has a slope of 0. Tangent line tangent to this has a slope of 0. Why? Because the tangents are all horizontal. That's why we are doing that. If you will get the first derivative, set that one or equate that one to 0. Okay, set that one to 0. And then, of course, if you will equate that one to 0, solve for the values. That will be the critical points. Okay. Again, since these points are horizontal, have horizontal tangents, that's why we are equating it to 0. Okay. To determine the type, okay, since if we will equate that one, we will be solving for values of x. But we do not know what kind of critical point is that, whether that is a maximum, a minimum, or an inflection point. So how are we going to determine what type of critical point is that? Okay, to determine the type of that point, of those points, investigate the left and right intervals. So that is where we will be using the intervals that we discussed a while ago. Investigate. So if the left interval is going down and the right interval is now going up, what is the point in the middle? Okay, that is how we will know if what type of the critical point is that. Okay, so that we will categorize according to the given description in each type of critical point. So the description is already given on this previous slide. Okay, so we will have an example here. Find the critical points of y equals 5x minus x raised to 5 and sketch the graph. Okay, so we will be finding the critical points. We will find the critical points of this curve, this function. And then after that, we will sketch the graph. We call this one the curve tracing. Okay, if you will go to your syllabus, you consider a curve tracing or polynomial curves. This is the topic. Okay, so we will now make use of the critical points to sketch or to draw the graph of the function almost accurately or accurately. Not unlike on before that we will just assume value of x or for y, plot those points and then connect, that is the curve. Right now we will be making use of the critical points only. Okay, and then after that plot the critical points, trace the curve. Okay, so solution again, how do we know the critical points? Equate or set your first derivative to 0. So I will first find out the first derivative of this. So get the first derivative. This is just a simple power rule. Okay, so derivative of y is y prime. 5x is 5 dx, or that is only 5. Minus, this is power rule. 5 will go down, x 4. Okay. So that is your first derivative. Now I will set that y prime to 0 or equate that y prime to 0. I will just make the value of y prime to 0. So that will be 0. And then in this equation, you will only be solving x since that is the variable. Okay, so if I will now play around with this, that is algebra. Transfer and then solve for x. You will have here x 4 raised to 4 equals 1. But we are solving for x, so get the fourth root. Or get the square root of x4, that will become x squared, and get again the square root. Okay, so no worry about 1 because the square root and the square root of 1 is still 1. But as I said on the previous discussion, a square root will always have a positive and negative value. That's why x1 here, you have two values, x1 and x2, a positive and a negative 1. Okay, so these are now values of x. Okay, these are now a critical points. Later on, we will solve the partner of this, the y partner on this part. But first, let's try to come up with the interval. Okay, if we say interval, that is the range. So if we say negative 1 and positive 1 are critical points, then okay, from a negative value up to a negative 1, or let's say negative infinity to negative 1, the movement is single. The flow of movement of the points is single. So that is one interval. So we will have a first interval here from negative infinity to negative 1. So it will be arranged from a negative values going to a positive. Okay, so which one comes first? Negative before positive 1. So starting from a negative number going to negative 1, that is one interval. And then from negative 1 going to positive 1, that is another interval. So I will put that as I sub 2. And then of course from positive 1 going to a very big number, positive infinity, that is another interval. Okay, so we have here three intervals. And in between these three intervals are your critical points, negative 1 and positive 1. Okay, so how do we know what type of critical points are these? We are going to investigate the left and right intervals of these functions. Okay, so we will investigate. So if we say investigate, how do we know? How do we know if that's an increasing or decreasing function or interval? Since this is arranged, it means that the movement is single. You can just get a number within the range. Get a number in between. But of course, do not get the limits. Do not substitute their negative 1. Do not substitute their negative 1 and negative infinity, because of course, those are the points. Or let's say those are the boundaries. Get a point within or between. So think of a number. Just think of any number within the range negative infinity. So it could be a very big negative value. But of course, that will be a very big value on the computation. So I'd rather use here, okay, I will not use again negative 1 since that is a critical, that is a boundary. So I will get, let's say, near negative 1, which is negative 2. Let's say try x negative 2. So that is within the range of your first interval. I will substitute that one to my slope. Isn't it? Slope is the first derivative. So that I will test if that is going up or going down. Okay, so I will substitute that one. And you ended up here with negative 75. Actually, we do not care about the value. What we care is the sign of the answer. Since y prime is the slope, again, it means that the slope is at negative 2 is negative, or the slope is going down. Therefore, if that is going down, it means that any point within the range of your interval 1 that is decreasing, that will always be going down. So you can say now that your first interval is decreasing. Okay? Again, just get a point within the interval, test the slope of that, substitute that one in your y prime since that is your slope, and then the sign will dictate if that is going up or going down. Okay, even if you will try other values, let's say negative 3, negative 4, and so on and so forth, that will still be negative. What only changes is the value, but not the sign. So let's try to test the other or the second interval from negative 1 to 1. So get a value from negative 1 to positive 1. So for me, do not use the extreme values, the negative, since the negative 1 and positive 1, since these are your boundaries, these are your critical points. So get a value within. So let's say this is value between 1 and negative 1 is 0. So I'd rather try x equals 0. So if I will try that one, substitute to the value of x, then that will give me 5. Okay, so y prime is 5, or that is positive. So what does that mean? The slope at x equals 0 is going up. So any point within that range of negative 1 to 1 is always going up. Pataas lahat po yan. So therefore I can say that the interval from negative 1 to 1 is increasing. And then of course we have one more to test, from 1 to infinity. Get a number from 1 to infinity. Let's say I will try 2, that is within the range. Substitute, that will be negative 75. Okay, negative 75. So again, negative, it means going down. Okay, so those are the three intervals. First interval from negative infinity to negative 1 is decreasing. From negative 1 to 1 is increasing. From 1 to infinity is decreasing. Okay, so these are your three intervals. Where are we going to make use of these three intervals is, again, we will make use of that to investigate what type of points are these critical points, negative 1 and positive 1. Okay. Okay, so let me, okay, sige. Before knowing if that's a minimum or maximum, we are talking here of points. So if we say points, it should be complete. It has x coordinate and y coordinate. So I will solve the partner of your negative 1, the y coordinate of that. I will solve that one, of course. Where will I solve that? Go back to the curve. Balik ka sa curve. Okay, go back to the curve. Solve the value of y there. Why? The points that we are considering is a part of your function or a part of the curve. So where will I get the partner of the x? I will get that one from the equation of the curve. Okay, so substitute your negative 1 to your equation. Since y is already separated there, that is simple. So substitute, you will end up with a y of negative 4. So you have a critical point at negative 1, negative 4. This is a critical point. Now, what type of critical of this? So look at the look at the left and right intervals. Okay, left and right. So within your left of negative 1, negative 4, okay, within the left of that is your interval. Okay, if you say within the left, look at this, your negative 1 is in between interval 1 and interval 2, right? Okay, look at this, from negative infinity to negative 1, negative 1 to 1. So it means that the middle of this I1 and I2 is your negative 1, negative 4. Again, the negative 4 is just the partner. That is just a partner y coordinate. But we are talking here of the x, which is negative 1. So if the I1 is decreasing, it means going down. Your first interval on the left side is going down. And then the right on the right is going what's that? Going up. Okay, so going down. So this is decreasing, and then increasing. So going down, going up, what is the point in between is a minimum. So we have here a minimum point. Now we will investigate the positive one. I will first solve the partner of that, the y partner of that, or y coordinate of that, going back again to the curve itself, substitute, and then solve for that. That will give me positive 4. So you have again a critical point at positive 1, positive 4. But what is that type of critical point? Okay, investigate your left and right intervals. So what is the left and right of your x1, x which is equal to positive? Sorry, this is supposed to be x2. Okay, please, this is supposed to be x2. X1, yes, that is supposed to be x2, the other one on the top, but it doesn't matter. Okay, that's supposed to be x2. Okay, so what is the left and right side of your positive 1? Is your interval 2 and interval 3. Interval 2, interval 3. What is interval 2? That is increasing. What is your interval 3? That is decreasing. So what is the point in between? That is a maximum point. Okay, therefore you have a maximum point at 1 and 4. Okay, if you are confused of that one, we have here a figure. So again, this is your first interval from negative infinity to negative 1, and then second interval from negative 1 to positive 1, and then the third interval, I mean, from positive 1 to infinity. I used the grapher again to draw this one, just like what we did on the previous discussion. So this is the drawing of that. That means that will continue going up if you will go to the negative. That will continue going down if you will go to the positive infinity. Okay, so again, this is what I'm saying, going down and then going up and then going down. So just investigate. How do you know that negative 1, negative 4 actually without even sketching, okay, without even drawing this one? The left interval, which is your I1, is going down, and then, okay, by the way, your movement is always from left to right always. Okay, so interval 1 is going down, interval 2 is going up, therefore the middle point is a minimum point. Now the 1, 4, that is going up, going down, therefore the middle point is maximum point. Okay, so that's it. This is your figure. So yeah, now on the fourth unit, okay, on the fourth unit, this is what we call the significance of second derivative. That is the importance, or that is the use of your second derivative. Okay, if the first derivative of a function is the slope of the tangent at a point, okay, we discussed that one a lot of times. First derivative is always the slope of the tangent line at the given point. So that is the first derivative. How about the second? Okay, the second derivative is the opening. This is now what I'm talking about a while ago on the inflection point. Opening. Saan nakaharap yung opening ng curve? Nakaharap ba sa taas? Nakaharap sa baba? Okay? So the second derivative is suggesting the opening of the curve at a certain point. We call that one the concavity of the curve. Okay, so if we say it opens upward, naka-upward yung curve natin. Okay, that opens upward, that opens downward. That is the concavity that we are talking here. So the second derivative describes a critical point even without investigating the left and right intervals of the same point. Okay, so that is the advantage of this. If you know the significance of second derivative, you do not need to be identifying these intervals already. Okay, you do not need to know those intervals. You do not need to investigate if that is going up, going down intervals, if you know the second derivative. Again, why? Because the second derivative again is the concavity or the opening. So we will make use of that. Okay, so the second derivative describes the critical point even without investigating the left and right intervals of the set point. This process is called second derivative test. Okay, so that is what we call the second derivative test. That is SDT. Other inflection points that are not given by setting the first derivative to 0, okay, can be identified by setting the second derivative to 0. Given below is an outline for identifying critical points. Okay, this is an outline for that. But let me explain this one. Just like in the problem example a while ago that we solved, we only have there a maximum and minimum points. We do not know if there's an inflection point or none. But according to our solution, and by investigating the left and right intervals, we did not end when we set y prime to 0, we did not solve any inflection point. But again, it says there that it could be the other inflection points can be identified if we will set now the second derivative to 0. Why? Okay, this is now the explanation. If you say critical points, these are three types. Okay, the maximum, minimum, or inflection. So tatlo po yan, maximum, minimum, or inflection siya. And all of these has a first derivative which is 0. The slope or the slope of the tangent are all 0. So the y prime of that are all 0. Now, on the second derivative of that, okay, this is now the outline of the second derivative. For a maximum point, the second derivative or the y double prime of that is negative value. Bakit negative? What do we mean by negative? That means opening downward. That is the concavity that I am talking about. So, a maximum point is located on a curve that is opening downward. So, ibig sabihin, yes, naka-open siya downward kasi yung pinakamataas na point na yun, yun yung maximum. So, yung curve natin is naka-open ng downward. Isn't it? Did you get the picture? The point, the maximum point is located on the top of the curve that is opening downward. Okay. So, look at this. Without even knowing the intervals on the left and right side, if you know the opening of the curve where the point, critical point is located, you can say if that is a maximum. Because if that is going down, maximum. Okay, on the minimum, it is positive. Why? Because it is now opening upward. Positive meaning opening upward tayo. So, yung point na yun is nasa baba. Ibig sabihin, minimum point yun. Okay? So, minimum point. But, if we say inflection point, okay, if we say inflection yan, inflection point, the first derivative and the second derivative are all 0. Okay, the first derivative and the second derivative are all 0. And this is just a secondary if your y triple prime or triple prime is not equal to 0. But actually, it doesn't matter. The important here is that your first derivative of that point is 0. And then the second derivative of that point is 0. We call that one the inflection point already. Okay. So again, that's why, look at this. If I will set the y prime to 0, since all of these points has 0 y prime, then that will be giving me a maximum, minimum, and inflection, but not all inflection. So if, let's say, there are some inflection that is not given, we will get that one by setting your y double prime to 0. Why? Because the y double prime of inflection point is 0. So ganun lang po yun. So, yung hindi natin nakuha with the inflection points that we did not get before from the y prime, we will get that one from the y double prime by equating to 0. Okay, again, I will repeat. Okay. If you will get the critical points, equate the y prime to 0, then solve for the values of x. And these values of x, we do not know if this is a maximum, minimum, or inflection. So, we will investigate that one by using SDT, the second derivative. So if you will say at the first value of x, you will solve the second derivative of that. It means that will give you a positive. It means opening. Again, second derivative is opening. If the first value of x will give me a positive double prime, it means that is located on the lowest point. So that is a minimum. If that will give me a negative, it means the curve is opening downward. The point that I'm investigating is maximum point. Okay, so that is the second derivative. We will have this example. We will go back to the example. Okay, the same example that we solved a while ago. So, okay, again, solution. Since I will be needing this y double prime and so on and so forth to y double prime and y triple prime. Actually, you can, okay, wait. Okay, so what I did is that I erased the y triple prime. So don't worry, in your final copy of this module, wala na yan. So that you will not be confused. Okay, so a while ago also I deleted. Meron dong other and y triple prime is not equal to 0. But you will just be confused with that. So again, let's just say that the first derivative of all of these are all 0, and then the second derivative of inflection is 0. Okay, so please focus on that. Now, so let's solve again without using intervals, okay, without investigating intervals. So we will be using second derivative, okay, so second derivative test. So again, for me to solve the critical points of this, I will get the y prime and equate to 0, and later on I need to know the opening of the curve, so that will be the second derivative. So I will be needing the y double prime. So y prime again is this, get the second derivative again, apply again the derivative, that will be y double prime, 0 po yan, magiging negative 20x3. So that is your y double prime. We will be needing that one for the SDT or second derivative test. So again, equate the first derivative to 0 so that we will get the critical points. It's either maximum, minimum, or inflection. Kung wala mang binigay na inflection doon, kukumpletuhin natin yan by equating the y double prime to 0. Okay? So again, the same. You will end up with x1, x2 to be positive and negative, just like a while ago, and then solving that one, the partner of those. Okay, so you will be having the partner of negative 1 to be negative 4. Again, please change that one. Okay, let me change it so that you will not notify. Okay, that I just changed that x1 x2 so that you will not be okay asking about that. So where's that? Saan na tayo? Dito. Okay. So I just changed that you will not be confused, since I put there x1 to be 1, x2 to be negative 1. Okay. So again, let's forget about the intervals. Let's forget about the intervals. Let's focus on the second derivative. We will be using that to figure out what type of critical point are those. Okay, so I will be solving the partner. Okay, let's say I solve their positive 1, negative 1. I will solve the partner of this. So negative 1, substitute back to your function, you will end up with negative 4, just like a while ago. And then get the partner of positive 1, substitute on the curve, you will have positive 4. So we have 2 points at negative 1, negative 4, and positive 1, positive 4. So let's forget that we know already that that is a maximum or minimum. Let's forget about that a while ago in the interval. So I will be applying now my second derivative test. I will know the concavity or the opening of the curves. Okay. So let's start with the first one. At negative 1, negative 4. So that is my first critical point. I will test that one by second derivative using your y double prime, get the concavity. Substitute the value of, since we in this y double prime we only need x, right? So we only need to substitute their negative 1. But in other equations, you will be having their x and y variable, you will be needing this negative 4. But for this case, we only need x, since that is your second derivative. So substitute there negative 1 on your x cubed, that will be giving us a positive 20. Again, that positive there, meaning of that is opening upward. Ibig sabihin po yan, naka-open siya upward. So the point negative 1, negative 4 is located on the lowest part. So that is a minimum point. Okay? And which is the same as our answer in using the interval. Okay? Using the intervals, that is a negative, or I mean minimum. Okay, so again, we figure out using a second derivative test is dt that it is opening upward, so that point negative 1, negative 4 is a minimum. Now let's try to test using SDT or 0.14. If I will substitute there x, which is positive 1 in your x cube, that will be giving us a negative 20. So again, negative means opening downward. So what is that 0.14? That is located on top. So that is a maximum point. Okay, maximum point. And then of course, by equating this y prime to 0, we only have there 2 points. Negative 1, negative 4, and positive 1, positive 4. We do not know if there is any inflection point. So as I've said a while ago, not all inflection points are given by equating y prime to 0. So the others, since again, only inflection point has a 0 y double prime. So equate natin. Equate your y double prime to 0 so that you will get the other inflection point. So I will equate the second derivative to 0. So where's that second derivative? Okay, I will now equate this one to 0. Equate it one to 0. You will be solving their value of x to be 0. So we need the partner of that. Solve the y coordinate. Go back to this. Substitute. That will still be y, which is 0. So you have a point 0, 0, or that is the point of origin. And do you need to test that one? You do not need to test. Why? We equated your y double prime. So only inflection point has a y double prime, which is 0. So automatically, what we get there is inflection point. Okay, we will only test those points that we get from first derivative. But the points that we get from the y double prime or the second derivative, automatically those are inflection points because those are the only points that has a y double prime which is 0. Okay, is that clear? So here is the figure again. Now, a while ago, using the intervals, when we investigated intervals, we only find out that there is a minimum at negative 1, negative 4, and a maximum at 1, 4. But since we already know the significance of second derivative, which can give us also the remaining inflection points that are not given, so meron na tayo. We already have there now a 0, 0, or at the origin, which is inflection point. Again, this is what I'm saying a while ago on the inflection point. If you will go back to the slide, let me emphasize this one, okay, so that you will know what is inflection point, difference of that with the other. Could also be known as the point where concavity changes. Okay, concavity changes. Since hindi siya clear dito sa drawing na to, let me show you on our example. Inflection point is where concavity change. Okay. Look at this one. The inflection point is 0, 0. If we say concavity, that is the opening. Okay. So on this left side, it is opening upward. Tama ba? Yes. In any points here, that is opening upward. Naka-open po siya pataas. And starting from this inflection point 0, 0, going to the right is already opening downward. So your concavity changes from going up to going down. So nagbago, and that point of change is your inflection point. Did you get that one? Okay. So okay, let me outline the concept. A minimum point, okay, here in the figure, a minimum point is when the change of interval from going down to going up. Okay, going down to going up. A maximum point is a change of interval from going up to going down. Inflection point, there is no relationship with intervals because that could be going up, or going down, going down. What you should know there is that opening up, opening down, or opening down, opening up, it is the change in opening. Okay, sa inflection point, change of opening na po yan. Hindi siya intervals. Okay, so opening na yung nagbago in your inflection point. So it could still be going up, but the opening will now change. Okay. So that is inflection, maximum, and minimum points. And this one, we will be applying what are these, since you might be saying that is that only for us to draw a figure? No. This maximum, minimum points has actual application on actual problems, like problem solving, as in problem solving, it's like algebra. That will be our next application. So that will be on the next video already. Okay. So are there any question? Comment below this video, and of course do not forget your activity to be passed on your canvas. The activity given on the previous video or on the yes, it is still on the file, or it is still on document or on the module that I will be uploading. So please look at that. Don't forget about that. That is graded. Thank you very much for listening.